Due to the adoption of technologies, there is an exponential growth of digital data, from terabytes to petabytes. For example, Walmart has more than 20 million transactions per day. YouTube has 30,000 hours of new content per hour. Same in education. Because of the adoption of e-learning systems and learning technologies, we can collect every teacher's and student's actions in detail. Everybody, including school administrators, want to exploit the value of these data and generate insights for improving teaching and learning. Learning ethics itself is a multidisciplinary subject. People from different fields contribute to this community. The first concise definition is from the first International Conference on Learning Ethics and Knowledge, LAK, 10 years ago. It says, learning ethics is the measurement, collection, analysis, and reporting of data about learners and their context for purpose of understanding and optimizing learning and the environments. It's not just about understanding how teaching and learning happened, but also about improving teaching and learning with a better and more relevant learning scenario. Definitely, learning ethics is about learning, so you will find studies on feedback, multi-cognition, collaborative learning, and self-regulated learning. It is also about data analytics. Prediction and recommendation is the core of learning ethics, and you will find lots of studies on all kinds of data, such as social networks, text, timing, positions, and movement. There are often studies on dashboard design and ways of presenting data to humans for actions. The discussions also cover participatory design and discussions on LA adoptions. Let's talk about typical applications of LA. Like other analytics, prediction is always the core application. The system can make predictions based on the existing data, such as behaviors of all students in the previous cohort, as well as the learning profile of the student in the past. If the system can predict that the student may be off track, the system can inform both students and teachers, such that teachers or systems can provide instant feedback to support students. For example, not every student in the US can complete a course or degree. The average completion rate of MOOCs is around 5% only, so responsively supporting students to be on track is very helpful. But in Hong Kong, most students can complete a degree, so at-risk prediction in Hong Kong context may not be that important, but it's still helpful if the system can provide personalized feedback based on students' current and projected status. Here is a typical process of prediction. First of all, we need a training data set for model training. The training data can be the quick stream of your course in the LMS, from conversations between teachers and students in the course, and student essays in the past, etc. We often need hundreds and thousands of student records for the training, and data must be structured for training. However, many data are in the PDF format or handwritten format. Most learning and assessment activities happen in physical classrooms and haven't been captured. Therefore, the obtained training dataset is not as easy as expected. Once we have the training dataset, we can select a training algorithm. Of course, you can use deep learning or other sophisticated algorithms for prediction. However, I suggest using simple algorithms such as linear regressions, logistic regressions, and naive Bayes. It's because it's easier for us to understand the analytics, interpret the results, and make actionable insights for improving teaching and learning. Once we have the trained model, we can import the test dataset, such as student behaviors of the current cohort, for the prediction. Prediction results can be shown to teachers or students through visualizations. Messages or warnings can also be sent to students automatically. Visualizations could be carefully designed such that teachers and students can understand, interpret, and take action. For example, we want to know how sustainable development goals have been taught in courses in universities. It's difficult for experts to interpret thousands of courses, so we can use prediction techniques to calculate their SDG relevance, and then report results based on visualizations. our training dataset comes from the OSDG public community dataset, which the community had verified. Meanwhile, course descriptions of courses have been used for the classification. We use the multinomial logistic regression algorithm for the classification. Descriptive analysis at course level, frame level, and curriculum level can be included to illustrate how SDGs have been taught in the courses. Another application is on analyzing the process of learning. In the past, if the class had hundreds of students, there could be 100 groups of discussions at the same time during the course. Teachers cannot understand the learning progress of every student. How do they communicate with peers? How do they think about learning? The system can check forum posts, course wikis, and e-learning usage history, and visualize students' behaviors to students immediately. The system can guide students through the collaborative learning process or creative writing. The system can also pair up students together for more effective group interactions.